I just want to show you a couple of things on the home page, the news. So there's a link here for students that would like to get some help from a peer tutor. So we've got a peer tutoring sort of facility going on. They're calling it a help desk, but it's peer tutoring. So if you follow that link, you'll see that there's a timetable where you can drop in this room, which is 229 upstairs. And the names here are names of students that are been at the college a little longer than you have. So they're confident in their IT and they don't mind to help other students in their IT. So you could go and you could join these students at these times in that room and they would help you with any questions that you have. Now, when I say they'll help you with any questions that they have, that doesn't mean that they're going to do your assignments for you, but it does mean that they could sort of clear up any misunderstandings that you have. Those students have been kind enough to actually leave their mobile numbers, some of them, and they've certainly left their email addresses so that you could contact them also, maybe if these times are not convenient for you, I guess. Now, when I say that, you know, they are students, so they got to study. So, I mean, you know, they're not going to be available 24/7, but they have volunteered, so that's nice for you. Maybe you can take advantage of that. What else? Oh, yes. I have put a video, and I won't show you this video in class because you can watch that anytime you like. But this fellow has done a pretty nice job on explaining Boolean algebra, which is kind of the topic of what we're doing today. We're not looking at it in exactly these terms, but some of you might be able to relate to the idea of doing tables, truth tables. So you may have seen something like that. That'll be a nice review for you. It's a 5-minute video to watch. And the thing that I want you to get out of it, if you watch it, and I am encouraging you to watch it, that's why I put the link there, is look at the concept of not, because we're talking about that today with our Boolean, not, and also the concept of and the concept of or, because that's what we're talking about in our lesson today. So hopefully that will be of some help to you.
One more question about the test Tuesday.
Yes, there's a test on Tuesday. There should be a note in D2L on the homepage about that. Yes. Okay. So the test that's coming up, your test. Okay. It's kind of lucky for you guys because you have a class tomorrow and then you have, so the test for you is the 3rd lesson of the week. So that's good. So the test will be 30 multiple choice questions of similar type to the type that you've seen in your quizzes. To be fair, without giving too much away, yeah, probably some of them will be the same as some of the stuff you've seen in your other quizzes. But and maybe that's why I'm not going to let you look at the old quiz questions, right? All right, so there's a bit of a hint. So there'll be multiple choice questions of 30. Then you will have a flow chart that you have to draw. You'll be given a problem, and you'll have to draw a flow chart to solve the problem. And so the test, you'll be given 70 minutes to complete it. It will be under the most secure sort of exam conditions that we have. So what I mean by that is that you'll have lockdown browser. You won't be able to use your phone or your calculator or anything else. It's just you and your computer with one window and me walking around looking at you. It'll be like that. Okay. So you have 70 minutes. The test includes flow charts. So yeah, that's up to lecture 9, I guess. So no, I don't think you're going to have to do selection. I haven't looked at that too hard. Maybe. Well, I mean, today we have to talk about selection, which is putting an if then else, or, you know, the diamond. Did we have diamond in lecture 9? We didn't do anything with the diamond in it. Yes. There'll be one question on the flow chart where you have to do the drawing. Now, there may be another flow chart question in the multi-choice, but I don't know. Okay, are we good with that? Why have I got that? You cannot minimize when you are recording the meeting. Oh, well, that's weird. Oh, well, I was trying to share the screen. There we go. But if I share the screen, I can't now. You know, I'm going to run out of time in 40 minutes. So I'm going to try and go and talk fast. Is that all right? Then we'll do all our other stuff later. Okay. So selection, we also refer to this, we use the term branching. And if you look at these little images we've got here, this is the meaning of branching that we mean, where you come in with one point of entry, but you can go you can go one way or another. In this case, we come here, we could branch out here. Each of these is a branch, right? We're branching here, we're branching there. And all of those branchings could be represented by if this some condition is true, then I go that way. Otherwise, I go that way. You know, that type of thing. So that's the kind of branching that we mean. And that's what we mean by selection in this context. So the point here about the CPU, you'd remember the fetch, decode, execute cycle from like lessons 1 or 2 or something like that. That's the way the CPU works. But you might remember also, we looked at some of those machine code programs, you know, level 2 programs. In that they had a ability to do a jump, and you could jump back to another line of code or jump ahead to a line of code. That would be like branching, or that would be a selection. Now, in those old programs, we didn't have a if, right? But you could do a jump. You could jump if some condition was true. So it was equivalent to an if. So we can change the program flow. That means we're going to, instead of going one line at a time, every line one after another, what we can do is we can branch. We use an if construct to do that. We can also branch back to a previous bit of code so that we keep repeating. And we've done that in class. Remember the punishment thing, right? I will not copy 100 times. We used a while, but there was a condition in there, right? While, as long as we didn't do it 100 times, we have to keep doing it. So there was a condition. But we've got 2 different types of conditions here that we're talking about. We got a while and we got an if. There's actually another one called a for, which is kind of similar to the while. I don't know if you're even going to need that this time, but all of those are going to have some condition in them. By the way, a for is just a special while without it's shorter to write, you know. So once you understand the coding of it, it's kind of like a while. So a condition, if a condition is true, then we execute a certain way. Otherwise, we don't. It's just simple as that. Now, we have a special word for it. We call it Boolean, and that's because of this gentleman here whose name was Boole. And so that he was a mathematician, and he described this kind of logic mathematics with logic, which we refer to as Boolean algebra. Now, I say he described it because I personally believe that the Greek philosophers, Socrates and Plato, more or less described this kind of stuff too, but they didn't call it, you know, they weren't working with computers. So we have this idea of a Boolean statement, which can be either true or false. And so here's some examples. John is hungry could be either true or false, right? It can't be true and false at the same time. It's either true or false. You know, so depending on how long ago it was that John ate, he's either hungry or he's not, right? He just got up from a meal, he's not hungry. Toronto is the capital of Canada. That's false. So, I mean, that's a Boolean type statement. So if somebody said that as a condition, we'd have to go and do the false thing, because I don't know if you know I don't know if you know or care what the capital of Canada is, but it's not Toronto. It's Ottawa. But now age. So if we asked somebody their age and we stored it into a variable called age, and then whatever that was, if they were more than 18, then this would be true. But if they were 15, this would be false. Name is less than 2 characters. If it's less than 2 characters, it wouldn't be a string. Yeah, could you have a name with only 1 character? I don't know. So that's probably false. But I suppose somebody could have a name that was 1 character. Those are Boolean because each of those could be described as either true or false. Now, we've got some other things which are not Boolean. How old are you? That's a question, and it's not true or false, right? You know, you answer it and you say how old you are. 2 and 3. It's not true or false. If we said 2 plus 3 is equal to 4, then we can say that was false. But 2 and 3, that's not true or false. So here's an example, which could be a real life example. I mean, businesses do this all the time. If you buy enough stuff, we're going to give you a discount of 10%, but you have to buy enough stuff. Now, in this case, enough stuff means that the invoice value is 1,000 reals. If the invoice value is less than 1,000 reals, it's not enough. So the condition to be true is that the value of the invoice is 1,000 or more. So we could put that into a flow chart. Now we're going to do something which you said we haven't done yet, which is to add a diamond to this. The diamond is going to fit somewhere in between these inputs and outputs. We've got an input here, which is how much are you going to buy? We got an output here, which is saying that you have to pay a certain amount. Now, somewhere in the middle there, we're going to have a decision. Decision is going to be represented by a diamond, and the diamond is going to have a condition in it. The condition is going to be, is the invoice amount over 1,000?
Yes or no question or a choice?
Yes, it is. It's a choice. It's a decision. So it has a condition. You're right, Omar. And the condition is either true or it's false, or yes or no. Yes or no is true or false. Just another way of saying it. So here we have the amount is more than 1,000. Yes. So if it is more than 1,000, we get to implement this little process, which is going to give the discount. Because you can see what's going to happen is the amount is going to be reduced by 10%, or it's going to be multiplied by 9%. But however, if it's no, then we skip that. All right. Now, how this would be implemented in a computer program, it would be implemented with an if condition. Do this, and that's it. Because if the condition is not true, all we do is skip it. We skip this process. If this condition is false, all we did was skip it. Both of these, whether it's true or false, we're always going to do the rest of this stuff. But if it's false, we skip one process. Does that make sense? That's done in computing with the if condition, do something. There's no else. The else only happens if we have two choices. Here we just had one choice. If we do this, if it's true, we do this. Otherwise, we just skip. Got it? That's an if. That's a simple decision. Here it refers that to the consequence. The consequence is the thing that comes after the then in an if then. There's no else. So there's only one thing that can happen. You either do the consequence or you don't. And when we're done, we skip on to the next line of code. Thank you. So here's another example, pretty much the same example in terms of what the flow chart looks like. What we're having is we have a simple condition. The condition is either true or it's false. If it's true, we do something. If it's not, we skip. No else, we just skip, right? So if the person is more than 18 years old, we give them a menu, and then we take their order. If they're not 18 years old, we just take their order, but we always take the order. It's just that if it's true, we got one more thing we're doing there, right? If it's not true, we skip over that. Now this one, look at this one. How is this different than the one before? Here we've got two choices. And so how that would be represented in a computer program would be if the condition is true, then else. So the if and the else, they work as a true and a false. I'm sorry?
Can you please repeat one more time?
Yes, I can. This represents two choices. So what we do with two choices is we have to have an else that goes with our if. All right, so if it's true, we're going to do this. Else, we're going to do this. Now, these things are mutually exclusive. That means we can't do them both. We do one or the other. All right. We've got two different menus. You don't get to see both. You only get to see one. If you're bigger than 12, you get the normal menu. If you're not bigger than 12, you get the kid menu. And that's it. So you don't see two menus, you see one or the other. You will see one or the other. All right. You'll definitely get a menu, but it'll depend on this. And then you go on and do the rest. That would be represented in a computer program with the if, then, else. If this is true, then we do this. The yes or the true is the then. Else, the false. We go and do that. Okay. So that's how that would look in a flow chart. Here's another example. Now we're getting into what we call a nested if. Nested if, what it is one of the conditions being true or false, we then follow that up with not just another process, but with another condition. Okay, so we've got a condition after a condition, or a selection after a selection. Now, what's important about that is, look at this. Age is less than 55. We don't ask this question unless this is true. If this is false, if the age is less than 16, we never come to this. Does that make sense? We never come to this. We only come to this if the age is over 16. And the reason for this is, as it says, this is some kind of extreme sort of like a ride. And I guess they don't want people that are over 55 to go on the ride, and they don't want people that are under 16 to go on the ride. So the question is the person more than 16? If the answer is no, then they don't go on the ride. But if the answer is yes, then we have to ask them one more question. Are they more than 55? Well, if the answer is yes, then, oh, sorry, are they less than 55? If the answer is no, then they don't get to go on the ride. I think that's pretty mean, actually. Because I like to go on it now. If the answer is yes, they're less than, then they get to go on the ride. This would be how this would be represented in the computer program. If age less than 16, then if age less than 55, then we're going to do that. All right. Now, if age less than 16, else, don't ride. Right. But if it's true, then else, then don't ride. We can do this. If we have time at the end, maybe we can even implement it in Python. Okay. Now, the point that we've got to in this lecture, and this will sort of finish it off, is we're going to look at what if we put two conditions together in the same sort of decision box. We can do that. We can say this condition and that condition, or we can say this condition or that condition. We can put two conditions together using an and or an or. Actually, you can put more than two. You can put 3 or 4, all right? But we're just going to work with 2. When we have 2 together with an and, we call that a conjunction. And when we put them together with an or, we call it a disjunction. Now, if you have condition 1 and condition 2 as the decision in your flowchart, both of those conditions have to be true to get a true coming out. That's what it means. And means that both or all, if you have more than one condition, have to be true, or else the output is going to be false. Does that make sense? You'll see that in that video that I give you, that 5-minute video. This is, he does a very nice job with that, and he uses truth tables. Or is the opposite. So that's the other thing you need to think about. Or is opposite of and, in the way that we're thinking about this, because we're going to use a thing called not as well. Because when you apply not, you opposite whatever it's applied to. And so if you took this, we'll look at that in a minute, but you'll see that if you not an and, you get an or. And if you not an or, you get an and. So notting will make things the opposite. But let's look at how they're opposite. Condition 1, or. This time we're putting them together with an or instead of an and. Or condition 2 is true. What that means is the only way that condition 1 or condition 2 can be true is if only one of them or two of them or three or both of them are true, right? As opposed to the and one. The only way the and one could be true is if both of them are true. But this could be true if either one of them is true or if both of them are true. As long as one of them is true, we get a true out of the or. So there's a difference between conjunction and disjunction. And I'm going through this a little bit quickly. So if you're using an and, it's going to be false as long as one of those is not true. So if I said not condition 1 and condition 2 is true or not, then we could, when we not it, we change in the way we describe it, we change the and to an or. Likewise, if we have an or and we not that or, when we describe it, we change it to an and. And let's see what we'll do it with an example. All right. Conjunction, we're using an and between clean and new. The only way that this statement is true is if the car has two things happening. It must be clean and it must be new. If the car is clean, but it's old, then the whole thing is false. If the car is old, but it's clean, then the whole thing's false. If the car is dirty and it's old, then the whole thing is false. And so that's represented there. If I said not the car is old and clean. So now that we're getting to the negation thing, right? Not the car is old and clean. That can be represented as true if the car is dirty or it's old or it's both. And so you'll see that, do you see the or in there? When I knotted this thing, which was an and, knotting turns it into an or.
Where did you know? Any differentiation on the-
I'm sorry, it's not clear in the slide. I just did it by saying. So what I said was, I'm going to knot this statement. This statement says your car is clean and new. I'm sorry, it doesn't show it on the slide, but I'm going to say not your car is clean and new. And what that means is your car is dirty or it's old. Not clean and new means dirty or old. I'm sorry, I didn't get that. Yeah. Yeah, not reverses the logic. When you put a not there, it reverses the logic. And when you reverse the logic of clean and new, you get dirty or old. So here's the or.
For and I'm talking about the case or and not, okay, not and. For or and not, we only need to have one entry valid, right? Like one part should be correct.
For or, as long as one part is true, then the whole thing is true.
And also for not, right? Like
For not and, then it's like an or, so only one has to be true.
yeah. So like this statement, if he had is dirty or old, if he had either dirty or old, then not would be valid, right?
So what we're saying here, your car is clean or new, as long as it's clean or it's old or it's new, then it'll be true. So it can be clean and old and be true. It can be dirty and new and it will be true. It can be clean and new and it will be true. Now, when you not it, if you said not your car is clean or new, then we'd be saying that, well, your car is dirty and it's old. You know, knotting would mean it's dirty and it's old. If the car is dirty and old, then it's false. So if you knotted this, it would have to be dirty and old. So I hope you can see there what I was trying to get at, that when you do a not on an or, you end up with an and. So this was an or, and when we knotted it, we ended up with an and.
can discuss later.
Yeah, I think it's just by examples you'll see it. And do watch the video. All right, so let's negate these. Negate these would be like putting not in front of this. Not, this car is beautiful. Would be like saying this car is not beautiful, or this car is ugly. Right? This car is not beautiful. All right, not, next weekend, I will go to the beach or to the desert. Not. So what's another way of saying that?
Next weekend, I don't know if you'll be talking to them.
Very good. Next weekend, I will not go to the beach and I will not go to the desert. Because if I went to the beach or the desert, this would be true. And so by making this false, I cannot go to either of them, right? So that's what we mean by that. Next weekend, I will not go to the beach and I will not go to the desert. And the other thing is, this was an or. So when we reversed it, we had to do a and. When we reverse an or, we get an and. So what about this? When we reverse an and, we get an or, right? So what's this going to be? I like burgers.
I do not like or pizzas.
I don't like burgers or pizzas. Don't like any of that, right? That's a sad person.
So you just make the opposite of the whole sentence, even the line. You can say just I like burgers or pizza.
I don't like burgers or pizzas when I made it the opposite. Because it was an and, when I made it the opposite, I ended up with an or. All right, how about this one? This course is interesting but difficult. Now, but when we look at but, it's like an and. Okay, it's like an and. So the opposite is going to be, this course is not interesting or difficult. It's neither, right? It's not interesting or difficult. The but was like an and. All right, so here's another one. Here's an and, right? It's between 18 and 35. So the reverse of that would be?
He is less, no, he's more.
More than what?
More than 35 or less than 18.
Yeah, it had to be an or, right? Because when we opposited this, it had to be an or. It can't be both of those things. It's going to be one of them. It's going to be either younger than 18, or he's going to be older than 35. How about this one? Here's an or. So you can see that your answer is going to be an and, right? I got an A.
No.
And I dropped the course, and I didn't drop the course. Which one? I dropped the course. Yeah, all right. I did not get an A, and I dropped the course. Okay. Oh, I think we're at the end now. This is a nested if. What we're going to, let's not worry about the math on this too much. But what we've got a situation is we get a temperature, get Fahrenheit temperature, that's an input. And you would have seen this before. We convert F to C. And we've got a formula to do that. And then we take our C value. And if the C value is less than 0, then we're going to be, that's freezing. That's an output. But if that's not true, then we're going to see, is the C value bigger than 100? And if that's true, then we're going to have boiling. And if it's false, then it's just normal temperature, right? And so all of these things will come to an end. So what I might do here is I might output another thing here, which will say normal temp, normal range or something like that. Or actually, no, we'll say this is liquid water. right? Water that's between the temperature of 0 and 100 is liquid. Less than 0, it's freezing. More than 100, it's boiling. It's gas. So we're going to have liquid water there. And there's our end. And this will go to the end. And that'll go to the end. So nested if. Here's an if here. If it's less than this, then it's freezing. Else, the no is an else. Else, is it bigger than 100? If it is, then we boiling. Otherwise, we do that. Let's do this in Python. You don't have to, but I'm going to because I like playing with Python. To just show you how easy this is, because you'll be doing Python a bit later on too. So let's call this water phases or something like that. Maybe that's why I like it, right? So what we're going to do is we're going to input the temperature in Fahrenheit. So we just say that we got our Fahrenheit temperature and we input the temperature. We'll take it as an integer. You guys don't have to do this yet. This is like a couple weeks down the track for you. So we got our temperature. Then we're going to calculate our C. This is the calculation. Our calculation of C is going to be Fahrenheit minus 32. I don't know if you remember this formula. It's a pretty simple formula. Fahrenheit minus 32. Then we're going to multiply that by 5 and then divide it by 9. Yeah, please. And then now we're going to do our nested if. Okay, so this is how the this is what I want to show you is the nested if. Yeah, well, you guys are adults. I don't want to spend all my class time telling you to be quiet. I'm sort of hoping that you could just do that on your own. But thank you. That's fine. So I'm going to do the nested if. Well, actually, it's not. Why did I start with a while? If the temperature is less than, so we're doing our C temperature. If our C temperature is less than or equal to 0, then we're going to have our freezing condition. And so we just do it like this, and we're going to print that we got freezing. I'll actually print the temp. And I'll put that there. And then we're going to say that it's freezing. And now, this is the true bit. The true bit is here. This is true. This is here. Now we need to do the not true bit. How we do that. And so the reason why I'm showing this to you is so you recognize the pattern. So, I mean, when you see it in a program, you'll recognize the pattern. Oh, that's like my decision. My decision. Here is a nice little diamond. Here's how I do a diamond. What I do is I'm going to do an else. Right? Else. Yeah. And now actually in Python, we can do a thing called elif. So here we're going to have an else with another condition. And so now we're going to say that, well, what if the temperature is bigger than or equal to 100? Then we're going to do, yeah, and I'm too lazy to type all that. So I'm just going to copy it. So this, now we're going to say it's boiling. Because it's bigger than 100. And lastly, so that gets us to here, right? But what if it's not bigger than 100? Well, we got one other thing we can do. We're going to say else. So else is going to always be the false condition, right? And so if it's not bigger than 100, we're going to do and we're going to say it's liquid water. Which is your normal phase. Now, this is a nested if. This is what it looks like in the simplest programming language that we're using. This is what it looks like in a flowchart. Decision, decision, right? True, true. False, false, right? Then we got another decision, decision, right? True, it's there, that's here. False, there. Can you see it all on here? You see how they match up? All right, let's see if it works. So let's just call it water. Okay, so we're supposed to test it with 3 temperatures. We're supposed to test it with 20 degrees. 20 degrees Fahrenheit is like, it's like -7 degrees, approximately. Then we got another one, which is 120 degrees Fahrenheit. That's approximately, -7 degrees Celsius. This is approximately 50 degrees Celsius, kind of hot. And then we got another one, which is 300 Fahrenheit, and that's approximately 150 degrees Celsius. So this would be boiling, this would be freezing, this would be normal, right? So let's see how it works. So the first one is 20 degrees Fahrenheit, and it says it's freezing. It's about 7. So that's working. Run it again. Now we're going to try it with 120. And that's saying it's about 50 and it's liquid water. And then one more time. We're going to try it at 300. And it's boiling. You okay with that? So we see the program runs the way we want. What I want you to get out of this is the nested if, the nested if. We got an if statement here. This is the true, this is the false. The else or elif is always the false. It's always the false. And then because we made it an elif instead of an if, instead of an else, here we got another condition, right? Oh, sorry, here's the other condition. Is it bigger than that? If it's true, we do this, else the false. This thing here is the false. This was false twice, right? False here and false here. It's this. False, false, liquid. Make sense? Yeah. Right. So you don't have to do that program. I'm only showing you that because you will have to do stuff like this in a couple of weeks' time. Thanks for that. Halas. People wanted to do a tutorial, right? All right, so the tutorial was, oh, I'm finished with this. So let's look at the tutorial. Cannot minimize, all right, so I guess I need to go back and show the screen again. Sorry, so the tutorial was, where was it? Homepage, yeah. That was last time, right? The tutorial, this one? All right. So there's 2 exercises there. Oh, the flow chart. I just did the flow chart here. The difference, the simplified flow chart that we had last week had no, so we had a start and we had a get temp in Fahrenheit. That's an input. And then we had a process, which was, and so I just called it here, convert Fahrenheit to Celsius. So it's the same thing. But we actually had a formula, which is that Celsius is equal to Fahrenheit minus 32 multiplied by 5 divided by 9. And if we looked at our program, we'd see that's exactly how we did it. There's the process there, right? Fahrenheit minus 32, and we tested that, and we know that that works. And so then the other thing is, so this thing here is a print. Freezing, I think, doesn't have a Z in it, does it? So that was our process. Notice that this has got a right angle on it. Notice that this does not have a right angle on it because this is an input output. And this is a process. Process is a rectangle. Then we got another output. Now the output, you can do it two ways. You can do it like that. That represents a printed output. Okay. Or you can just do it as an output, which is the temp in yeah, it's a parallelogram here. Temp in C, and then you're done. This is the same flow chart with two decisions put into it, right? We put some decisions in it. I simplified the input outputs here by just showing the symbol and just saying boiling, liquid, and I simplified it.
So the one on the right is the exterior one.
Oh, so this is number 2. This is the Fahrenheit Celsius. To do it Celsius to Fahrenheit, you just input the Celsius, right? And the formula will be different, right? It'll be, well, what's Celsius to Fahrenheit? It's going to be times 9/5 plus 32. So it's the, you know, it's going to be, so Celsius, sorry, Fahrenheit, is going to be equal to Celsius times 9/5 plus 32. It's the opposite. So you would change this formula to this formula, and you would input C instead of inputting F, and then you would output F. So yeah, they're basically the same. Does that make sense? And then exercise 2, the big flash sale. You got 2 things going on there. 20% on all items. And then you've got a discount. If the item costs, okay, this is, I don't know, I'm tired. I'll show you something here. Oh, look at that, there's a solution. All right, so I don't want to draw it, so I'm just going to show it to you. So hopefully that doesn't need any more explanation, right? So we input the temperature in Celsius, we do the calculation, we output, right? Just like that. Okay, this is where this looks nicer. You don't need colors. You got the idea, right? Now look at the going the other way. It's the same. The only difference is we input the opposite thing, but notice inputs, outputs, processing, and start. And then we got this thing with the calculations, the discount price. It's the same. We got the same flow chart 4 different times with the different inputs and outputs. It's the same. What it is input, calculate, output. Got it? I mean, sorry, that tutorial, that was it. Input, calculate, output 4 times. Is that enough for the tutorial? Thank you.
Abdul
Rahman.
The rectangle decision.
Sorry?
The rectangle, when do you exactly use?
Okay. Rectangle is a process, as opposed to, we didn't use it when it was an input or output. In the input output, we just use parallelogram.
They get confused.
Don't get too hung up on that. When in doubt, just do a rectangle because it's a process, right? And I'll kind of go on with it, right? I mean, if you look on, if you look at the drawing.io, we had some other symbols for inputs and outputs too. We had some special symbols, like I use this symbol if you have a printed output. So we have some other special symbols that you can use. You don't always have to use a parallelogram. So I don't know if you saw this one, the printed output.
Yeah. Now you use that before or after the end, or
everything has to happen before the end. Once we get to the end, we're done. Yeah, once we get to the end, we're done. There's nothing else to do. Okay,
So this is due tomorrow.
yeah, so there you go. You had a pretty good look at it now. Everybody should get that right. Right, you guys are lucky. Not all my classes have 2 classes before the test. So we got another class next lesson. And I guess we can take questions about the test or whatever. You guys should be able to finish the tutorial in the lab. And yeah, so I got a class with you tomorrow. I'm not sure exactly what we'll do, but you should have, I mean, I think I already marked the lab, didn't I? Lab 4?
Yeah, I think we are done with that.
Yeah, I think we're done.
Is there another lab or
No. No, I think that's it. I don't know. I'll tell you if there's something else tomorrow, but I think we're done for today unless somebody's got some questions. You guys all right? Thanks, Dr. Ruffman. He's my policeman dude today. I do appreciate that. Really, I do. All right. Khalaas and Zain.